Hello grade 7 students! Welcome to my tutorial in week number 5 of quarter 2 with learning competency derives the laws of exponent. So we have the first law of exponent, powers of a product. The exponent of a power indicates how many times the base multiplies itself. In symbol, we have a raised to n is equal to a times a times a times a times a and so on, where n is a factor of a. For instance, if we are going to evaluate the following. Number 1, 5 raised to the third power or 5 cubed. So 3 is our exponent and 5 is the base. So it means to say that you are going to multiply the base 5 in 3 times by itself. And that gives 5 times 5 times 5 is equal to 125 because 5 times 5 is 25 times 5 is 125. Next, we have 2 is raised to the fourth power. The exponent is 4 and it tells the number of times you are going to make your base as a factor. And that is 2 times 2 times 2 times 2 and the product is 16 because 2 times 2 is 4 times 2 is 8. 8 times 2 is 16. Next law of exponent, we have power of powers. If the expression is raised to a number, is raised by another number, multiply the exponent. So your keyword in power of powers will be multiply the exponents. In symbol, we have quantity x raised to m multiplied by raised to n power, and that gives x raised to m times n. So m and n are exponents, so you are going to get its product. For instance, if we are going to evaluate 3 raised to the second power, and it is still raised to the fourth power, it is raised to another exponent and that is 4. So what are you going to do is you are going to multiply 2 and 4. So that becomes 3 raised to 2 times 4 and the product is 8. Therefore, your final answer is 3 raised to the 8th power. And go back to the first law of exponent. Okay, the exponent is 8. It tells that you are going to make 3 as a factor in 8 times. So that is 3 times 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 3, and it gives the product of 6,561. Another one, suppose if we are going to evaluate the quantity 2b squared raised to the fourth power, so we are going to start on the numerical coefficient, which is 2. 2 is also raised to the fourth power. So we can have 2 raised to the fourth power. And b squared is also raised to the fourth power. So based from the law of exponent, you are going to multiply the exponents. So that is b raised to 2 times 4. And that gives 2 to the fourth is the same as 2 times 2 times 2 times 2, and 2 times 4 is 8. Therefore, we will have a final answer of 16b raised to the 8th power. Another law of exponent, we have product of a power. When multiplying powers with the same base, keep the base and add the exponents. So what are your keywords in product of a power? Okay, as long as you are multiplying powers with the same base, the first thing to do is you're going to keep the base. So that's the first keyword, keep the base, and then add the exponent. So your second keyword should be add the exponents. In symbol, we have x raised to m multiplied by x raised to n. So the bases are the same. What are you going to do with the exponent? So you are going to get its sum, or you add x raised to m plus n. You always keep your base. Okay, suppose if we will evaluate 3 raised to the second power multiplied by 3 cubed, the base is 8. 3, I should say. The base is 3. Okay, so we have 3 raised to 2 plus 3. And what is 3 raised to 2 plus 3? That is 3 raised to the 5th power. Okay, to simplify 3 raised to the 5th power, you're going to make 3 as a factor in 5 times. So that gives 3 times 3 times 3 times 3 and times 3, we have 243. Next, evaluate 4x squared multiplied by 3x cubed. So the numerical coefficients are 4 and 3. So you multiply 4 and 3. So that gives 12. X raised to the exponents of the base, we have 2 plus 3, and that gives 12x to the 5th power. Okay, another one, we have negative 2y raised to negative 5 multiplied by 4y raised to the 9th power. So get the product of the numerical coefficients. We have negative 2 times 4, so that is negative 8. And the exponents of y are negative 5 plus 9. Okay, so you go back to the lessons in addition of integers. Okay, so if you are adding two integers with unlike signs, what are you going to do? So you are going to subtract and then copy the sign with the greater absolute value. So that is negative 8y raised to the 4th power, because 9 minus 5 is 4. 9 is greater than 5. The sign of 9 is positive. So you are going to copy the sign of 9. So we have positive 4. Another one, we have quotient of a power. When dividing powers with the same base, keep the base and subtract the exponents. In symbol, we have x raised to m over x raised to n, or that is the same as x raised to m divided by x raised to n. So the exponents are subtracted m minus n. Okay, for instance, if we are going to evaluate 5 raised to the 6th power over 5 raised to the 4th power, so you are going to subtract 6 and 4. So that gives 6 minus 4. So we have 5 squared. 5 squared is the same as 5 times 5, which is 25. Another one, suppose if we have 6b to the 4th power over 2b squared. The first thing to do is you divide the numerical coefficient. We have 6 divided by 2, and that gives 3. The exponents of b are 4 and 2. You subtract, starting on the exponent of the numerator subtracted by exponent of the denominator. So 4 minus 2, and that gives 3b squared. Another law of exponent, we have zero exponent. Any base powered by zero exponent equals 1. In symbol, we have a raised to 0 power is equal to 1 as long as a is not equal to 0. For instance, if we will evaluate 5 raised to the 0 power, it is equal to 1. 100 raised to 0 power is also 1. Same true to 22 raised to the 0 power, we have 1. Another, we have negative exponents. If the base is powered by negative exponent, then the base becomes reciprocal with the positive exponent. Okay, in symbol, we have x raised to negative m. Getting its reciprocal to make the exponent positive, so we have 1 over x raised to the m power. For instance, if we will try to evaluate 7 raised to negative second power, okay, so that is 1 over 7 squared, which is equal to 1 over 7 times 7, or that is 1 over 49. Another, 4 is raised to the negative third power. That is 1 over 4 cubed. So the numerator is always 1. Okay? The numerator is always 1, which is equal to 1 over 4 times 4 times 4. And we have 1 over 64 because 4 times 4 is 16, times 4 is 64. Okay, suppose if we are going to rewrite each expression using or with positive exponent, let's say in number 1, 2x raised to negative 3. Getting its reciprocal, so you will have 1 over 2x cubed. Okay, so very simple. Next, number 2, 3x raised to negative fourth power over 6y squared. Getting its reciprocal, okay, so we will start on the numerator. We have negative, or we have 1 over 3x to the fourth power all over the reciprocal of the denominator. We have 1 over 6y squared. Okay? The numerator, this one, 3x raised to negative 4. The reciprocal is 1 over 3x to the fourth power. And the reciprocal of the denominator 6y squared is 1 over 6y squared. Or you can have in horizontal, okay, in horizontal arrangement, you can have 1 over 3x to the fourth power divided by 1 over 6y squared. Okay, so to simplify the division of fraction, you can have cross multiplication. 1 times 6y squared. So this is now the result in the numerator, okay? And the other one is 1 times 3x to the fourth. This will be the what? The value of your denominator. And that gives, okay, so the first one, 1 times 6y squared divided by the product in 1 times 3x to the fourth is 3x to the fourth power. Okay. So you are going to simplify 6 divided by 3, and that is 2. So final answer is 2y squared over x to the fourth power. Next example, we have number 3. 2x raised to negative third power times y raised to negative fifth power. So getting its reciprocal, the numerator is 1 over the denominator 2x cubed y to the fifth power. So that ends our session. Thank you and have a nice day. Goodbye.